honored to be on this stage, and I'm happy that I can talk about a topic I'm passionate about, web application firewalls. From the title, it sounds might a bit late to the party, as Ingress NGINX has been retired more than 2 months ago, but I try not only to focus on the migration part of point, but also a bit more on what solutions there are around for Kubernetes WAF options and how to operate it. Maybe you've read it in the abstract. I'm a bit opinionated, so yeah, that's that. I'm Lukas Funk. I work as a senior solution architect at United Security Providers. More than 10 years I'm working with WAF, developing WAF, and implement WAF solution at our customers. For those who don't know us, we are a small company. Since more than 30 years, we work in the field of cybersecurity. Since recent years, we are a 100% subsidiary of Swisscom. We provide our own WAF and Next solutions, and also operate it as managed service for our customers. So let's get started with the main topic. I assume last November quite a few Kubernetes operators were taken by surprise, and it was also quite a tight schedule, 6 months, and then Ingress NGINX will not be maintained, so no vulnerability patching at all. And I find that number quite impressive. Every second Kubernetes cluster was running Ingress NGINX, so that's a quite big number. And I think it was the most feature-rich Ingress controller in the ecosystem. Probably that's also something why the maintenance was really a burden by the time. One of the features was that it had built-in WAF engine with ModSecurity and OWASP Coraza support. Yeah, I think that's probably the most widely used open source WAF engine in the world in combination with Coraza. So it's a really good solution. I personally think WAFs are still a very important puzzle piece in the whole security in-depth strategy. And especially, I think, in today's era of AI-assisted vulnerability discovery, it helps with features like virtual patching. If you cannot patch the backend application fast enough, you can enable a virtual patch on the WAF and roll it out over the whole system. What I like especially about Kubernetes deployed WAFs, in my eye, compared to traditional WAFs, which are like in front of a Kubernetes cluster, they move much closer to the application. So the configuration stays together. Any change in the application might result automatically also in a change in the WAF configuration, and you have much better history and auditability. And I think that's even better, or more important point, you have the same tools to operate and deploy the configuration of the WAF. So, what solutions are there available for installing or operate Kubernetes WAF? I will not talk about a lot of that. But if you're coming from Ingress, that's a question you have to ask. Do I want to go still with the Ingress, or do I want to do the migration? I think I would, as you have anyway to invest something, go always for the gateway API. It's much more convenient, and that's, I think, the solution to go, also recommended by the Kubernetes operator. Second part is you need a rule engine. So we have the veteran ModSecurity. He turns 25, so it's quite a long history. And in recent years, there is an alternative called Coraza WAF. It's a replacement, or it supports the same seclang, as we call it, so the configuration language of ModSecurity. It's basically a drop-in replacement written in Go. And both engines share that they have a lot of connectors and libraries, so you basically can integrate it in anything. That shows that quite nicely. These are all the Ingress or gateway controllers which support or are freely available and support in any way these the two engines. As you see, I've tried to highlight how they integrate it, because that is quite important why I came to the recommendation in the end. There are like three groups of integration. One is like the SPOA from HA proxy or the XProc, so an external container doing the whole analysis. The second group is WASM, and the third group is basically the native modules which we have in Envoy, or also Ingress NGINX was using the native module. A short comparison of these three integration possibilities. Those who know WASM, it used to come from mainly browser use cases. It uses a sandbox to run all the stuff in it. That's great. So it's portable. Any proxy who implements the WASM interface can use this same binary. A big disadvantage is due to the isolation, we don't have access to the file system. So all the rule set, if you have big rule sets, you need to compile them on build time. You cannot deploy a newer version of a rule set and access it directly. Then second, we have the external process. There the advantage is that we have file system access, so deploying of new rule set is much easier. But due to the architecture, we have additional latency, so we have an extra network hop, an additional container, so it makes the deployment a bit more complex. So that's that. And then you have the native filter. You have file system access, low overhead, and no latency, no extra hop, but it is development for each proxy. So we have to extend the native APIs, and there's no isolation. So if the process dies to anything, you tear down the whole proxy. When we started to look for a new WAF or rule engine, we basically had to look at all three integration. We started with proxy WASM, and there we had severe issues with it. So there was a huge memory usage, so the out of memory was reached quite quickly, and it also faced the same fate as Ingress NGINX. One of the core SDKs to implement the WASM interface, the Go SDK for that, was archived and not further developed. So there was like a dead end. Therefore, we looked at also the external process and compared that all performance-wise, and basically we ended up writing Coraza Envoy Go filter. So we always worked with the Envoy proxy. So I have to admit, HA proxy, I'm not familiar with it in detail. But the Envoy Go filter was the implementation of it proved to be very strong. We had massive performance improvements, and we were able now to update all our rule sets we wanted to do without building every stuff again. So yeah, they're public available. That's if you want to try it, that's great. And therefore, that's why I recommend to go, if you want to have Kubernetes WAF, go with Envoy Gateway. It's a very feature-rich Envoy Gateway, Gateway API, and use the Coraza Envoy Go filter to integrate or use the rule set, make use of the power of the core rule set. So now we have a a solution we want to go for, how do we get there? If you're coming from an Ingress setup, there is a tool from the SIG network called Ingress Gateway. It is not limited to Ingress NGINX. You can tackle quite a bunch of different Ingress controllers and emit different gateway, or it tackles different gateway implementation as well. It tries to include the annotation hell, which we had in Ingress, and tries to translate all these annotations at best effort to the new gateway structure where possible, and also writes nicely which annotations were not able to migrate. There are about a third of all available annotations in Ingress NGINX which are supported, so that's quite good. ModSecurity annotations are not supported. I think that's okay, because there's no native Envoy Gateway implementation with built-in security engine, but it's not really difficult to migrate this configuration into the new structure, as the language, configuration language used, the seclang, is identical. So that's great. And the good thing as well is you don't need to have the annotations part, but you can use, or you make use of the Envoy patch policy to include this Go filter. Quick show of hands, who was using Ingress NGINX or with the WAF rules? Anybody? A few? Okay, interesting. Good. I will not bother you with how to set up the Kubernetes or the Envoy Gateway. I think that's well documented, and yeah, that's not very helpful. So here's an example of the annotations for the ModSecurity. It's yeah, really basic. You enable it, you enable the curl set, you define how to map the request ID with the transaction of ModSecurity, and then you have options to use any seclang directives. Yeah, I don't know, the ones who are using it, I felt it's not, or using ModSecurity with Ingress NGINX was quite difficult, especially like the snippet is limited on length. So if you have and you have a lot of exceptions in general, you have to tune the WAF to configure that. It's quite challenging, I think. So we have this annotation. How would that look like in the Coraza filter configuration? That's native Envoy configuration, unfortunately. As it's not built in, you have to make use of that. Envoy Gateway has extensions points to use it differently. Like in the recent release, there was like the support for dynamic modules for Go language, or Go SDK for that. It makes this whole process a bit easier to use. But yeah, I haven't dwelled into that in detail yet, but that sounds quite promising and makes the configuration easier, I think, in general. So you remember the annotations from before. So that's just one line exactly. Here is another one to enable the curl set. And transaction ID, that's currently not configurable, but I don't think that's a big pain, because the request ID is the default, which is mapped to it. And then we can add the snippets as we're used to. So now we have a Kubernetes cluster, we have an Envoy Gateway set up, we have a rule engine which is running our configuration. Now the actual difficult part starts, because it will produce problems. And I think that's also why WAFs have a very bad reputation. And it's not, it takes time to tune it, but what I try is to show how you could tackle that stuff, that you don't get frustrated in the daily operations. The OWASP Core set has two very important features. One is the paranoia level. So it's kind of a risk level, and it defines how many rules are actually enabled. It starts from 1 to 4. 1 is the baseline security, 2 is like online shop, 3 online banking maybe, and 4 is for the crazy peoples who have to protect the atomic power plant. So yeah, it's not really difficult to or you get crazy there. And then we have the anomaly score. That's basically the sensitivity of the WAF. The rule set is designed that it not blocks automatically on the first violation. It's basically runs through the whole rules, and on every violation it adds up a counter, the anomaly score, and you define the threshold where to block the request. And this allows you to gradually adjust the security level over time, and that's also the important feature you can use to tune your system. So how is the general approach? The overall goal is to get to an anomaly score threshold, or reset the anomaly threshold of 5. So that means basically every violation blocks the request, because maybe you can go with 10, higher above, it will end up in bypasses more easily than that. So that's our final goal. So first you have to define your risk level of your application, what paranoia level you want to use, because if you start with a level 1 and then you want to go to level 2, you do a lot of iteration additionally, so better to define your paranoia level at the beginning, and then you have not additional iteration. For Kubernetes setup, I think that's a big advantage, because they're usually multi-stage setups. In traditional WAF, we have seen a lot of customers, we don't need a development environment, so we go live with every system. That's it doesn't help. But if you're a multi-stage environment, my recommendation is that you use it for the first time. You start up the WAF in detection only mode. You run all your tests. You do some manual testing and see if the application still works as it should. You should not get any blocks, but it will log any violation. So after that, you can go through your logs, accept all these violations as false positives, and then go into the production with that in detection mode, in blocking mode. So, but it's really important that in the first step, don't try attacks. So if your tests have text patterns, it's not a good idea to just blindly accept everything. So if you're done that, switch to blocking mode as quickly as possible, because I've seen a lot of clusters or WAFs which have been running in detection mode for years, because they were just so scared. If you now put it in blocking mode, it might interrupt my customers or whatever. So yeah, don't do it. Just go directly to blocking mode and make use of the anomaly score. Set it to a very high value, and then you can run it. And then you start iterating over the violations of the real traffic, which we see. And then you can say, okay, every day I look into logs, see what violations are there, accept it or not, and then you go gradually with the anomaly score down step by step until you reach the 5 or the 10. If you're at that level, there's one final feature which I recommend to enable. That's the called Sierra's early blocking options. The whole engine, the rule engine, is set up like you analyze first the header parts, or so the request metadata or header data. That's phase 1, and then there's a phase 2 which accesses the body data. And basically, if you enable the early blocking options, if you have any violations already detected in the header or the URL or anything, it will immediately block. So you save some computing resources because, yeah, depending on the size of the body, it takes an additional steps. Good. So as you see, it's quite a tedious job to do so, especially analyzing logs. That's probably our favorite job. And therefore, what I did is I built a small tool which helps me to analyze the logs and also write the exceptions I need. So I want to quickly show how that works. I have an application. For those who have never seen it, that's the Juice Shop. Softladen, it says it all. If you don't know it and you want to learn something about application security, it's a great tool because it's a flawed web application. There's a lot of vulnerabilities in it. If you want to try it, I recommend that you start with the login screen. That's a really easy one to find out, but I don't want to take all the fun out if you want to try it by yourself. So, what I did previously, I run a lot of requests over that. So basically I did the whole iteration one, saying I'm in development mode, I do normal requests, and I want to now see if there are any false positives. So I have the logs, I will pipe that immediately into my tool. What it shows basically, as the Envoy Gateway is a multi-vhost cluster, so there can be different names. So I have only one luckily, so that's good. So I can see that. You see all the paths which are which has violations. You see the score, even better view. One has no good. To start is, or to help to get down to the score level, start with the anomaly scoring. So that's the highest score which I reached was 30. So kind of 6 violations. We can look into that, and now we see all the rules, which paranoia level it was, which category it used, what message was, and also which argument and what data was used to, or what caused the violation. So as you see here, that's an image upload with base 46 encoded stuff. Yeah, I want to have the image upload, so I need to accept all this stuff. I can accept them as false positive. I've analyzed it. So this one, the first request is done. I can go into the next one. So that's the password field. Pipe characters in my password. That's also good. Yeah, it's possible that someone adds pipe character in the password. So you probably also need to accept this part. And so you go gradually through all these blocks or violations, step by step, and tune your system. Once you're done, we export. We get a list of SecRule languages which basically accept or create exceptions of the rules. That's detail here. So I can copy that basically then and add it to my configuration. And then, oops. Yeah, that's how it. And then I could apply it again, and next step, the next round, wouldn't these violation would not occur again. So as you see, it is a tedious work, but I try to show you how you can tackle that, and with tool support, I think that's the key thing. Of course, you can also build dashboards and stuff like that if you want, but I think you need tool support to tune your WAF. So if you want to try it yourself, I've published that in my GitHub repo. And so to conclude that, if you want to implement a WAF directly in Kubernetes, not with Cloudflare or what is in front of it, I would really recommend you use the Envoy Gateway. You have a great gateway API. Maybe you have been to the talk of Christopher, which explained how you can extend it as well. So it's really built for the future with the Go filter, or maybe in the future dynamic module. You have a very performant WAF implementation or a rule engine. You make use of the core set, which is a great baseline tool, and finally you have a tool to manage all these tuning stuff, and that you make your life easier if you have to operate the WAF. So yeah, that's my talk. Thank you for your time, and I'm happy to take questions and try to answer them.
Thank you very much, Lukas. Thanks.